Not far from General Fusion's headquarters, you can find another fusion company. Helion Energy, one of the most buzzed about fusion companies in the world, is hunkered down in some former Boeing hangars just outside Seattle.
What we have tried to do at Helion is approach fusion from a different direction than a lot of other people. We looked at the state of the art of what was being built in fusion and thought really there has to be a better way to get to commercial fusion faster.
That might sound like hype, but there really is something radically different about Helion's reactor.
Almost every idea behind a nuclear fusion startup or a company is to rely on the heat that is generated by fusion, and then converting that heat into steam, which is then used to turn turbines to generate electricity. Now, Helion says that it doesn't have to go through that heating and turning a turbine phase.
The company's $500 million Series E round makes them one of the best funded fusion companies in the world. They're also making one of the most ambitious predictions in the industry.
The goal is to get this built by 2024, running, generating net electricity from fusion for the first time. Timeline is the driver. It's always the driver. And so if it's a question of, well, it could be a little bit better, but take an extra year, we say, no, we're going to make it a little bit worse, but get it done a year earlier. It's a Silicon Valley mentality of how can you build as absolutely as fast as possible.
The idea behind inertial confinement is you hold plasma for a very short time in a very small space. So one example of inertial confinement is where lasers, very high-powered lasers, are used to heat a very small amount of hydrogen for nanoseconds, that is billionths of a second.
This has been done before, most famously at the National Ignition Facility in California. But First Light has come up with a new approach.
We call it projectile fusion. We have a high-velocity projectile. It flies in and it hits into what we call a target. And the target has to focus the energy of the projectile into the fusion fuel. This is one of our targets, and this is the key technology to our approach to fusion. So this is completely turned into a plasma by the force of the impact and the energy released. In a power plant, one of these targets would release enough energy to power the average UK home for over 2 years.
That sound? That's the projectile being fired out of this gas gun at around 15,000 miles an hour.
To generate power, you have to do that at a repetition rate. You have to do a certain number, and it's the energy you release every time times by the frequency, and that's the power. So in our power plant design, we'd be doing this about once every 30 seconds. So we recently showed fusion in our lab with a projectile-driven approach for the first time. Just simply experimentally, it's a big proof of concept that it can really work. If we look at the actual amount of fusion we produced, then that number by itself, it was 50 neutrons, so we're not hiding it. It's not very impressive. But the point is, that's exactly what the simulations predicted, and that's what gives us the very rapid, we hope, pathway forwards to improve that number. I hope we're not talking about 50 neutrons at the end of the year.
So there's these disruptive technologies which are coming into our space, which is great. We want new ideas. We want people to come and tackle the big challenges that we face. There's lots of startup companies. Some of them will fail. Some of them will go to the wall. Some of them will wildly succeed. That's just healthy.
Some on the scientific research side of fusion are more critical of the startup phenomenon. Few private fusion companies have shown any results beyond fusing a few atoms, and many scientists worry that these startups are promising too much.
The cons, in my mind, are the promises by companies who either have a concept that we have already, for good reason, put apart and knew why they won't work, or completely new concepts. Some change them every other year, and then they still promise fusion energy by 2030 or something. And I don't like that too much, because I'm afraid that if there are so many promises not kept, that this would not be positive for fusion energy in general.
If you look at the timescales that governments work at in research, That's completely different than the timescales that entrepreneurial private industry works at. It's not that there's a problem there with government, but they're a different set of metrics there. They're largely research-driven organizations. You need look no further than commercial access to space. SpaceX, they've created what people thought would never be possible, which is reusable rockets. NASA was never able to achieve that because they weren't motivated by the same things. And so when it comes to the last mile of commercialization, that's where you really need to hand the baton from government to private industry.
From what I know, some of the private sector is very serious and is bringing significant capital and significant engineering advances. It needs to promise things on a realistic time scale. So not next year, but and the time scale of about 20 years is realistic.
It remains to be seen whether the Silicon Valley VC type approach will actually get us to commercial fusion faster. One thing is for sure though, progress, however slow and incremental, is being made. And if we're going to get to a fusion-powered future, we're probably going to need both the painstaking research and the risky new ideas.
I think the rate of progress is really driven by the imperative. And to be honest, let's just be honest as a society, over the last 20 or 30 years, we've been pretty comfortable with burning fossil fuels. The fact that we have to stop it now drives imperative.
This is the most important question for mankind because, you need electricity or energy for everything. We have a lot of developing countries, and if these countries want to come to our standards of living, there's no way other than provide them with cheap energy and better CO2 neutral, otherwise we have a climate crisis.
Each fusion technology has a slightly different flavor in terms of its ultimate value proposition. And so I think that you're going to see a portfolio of technologies being commercialized over the coming decades that address different parts of the market. And the market is huge and diverse. The total addressable market for fusion is on the order of $1 trillion a year.
It might be decades before fusion becomes a reality, but it's the kind of cheap, unlimited power that you would want to give a civilization to be able to do all the things it wants to. Imagine if you could make a lot of rocket fuel to create an entire fleet of rockets that would go and mine asteroids because, at some point we're going to run out of metals. Or you could remove existing carbon dioxide in the atmosphere, back down and bury it deep underground. That process requires a ton of energy. But if you were able to create nuclear fusion, you could imagine restoring the Earth's atmosphere to pre-industrial levels. And these are the kinds of applications that really cheap and clean energy can enable humanity to do.